Thank you. Thank you very much, Jana. Thank you very much for the organizer of this data sprint, which is really, really a great success. I've been many times in Amsterdam at the DMI summer school and winter school, which are kind of the inspiration of this sprint. But I have to say the year is really as good as the one in Amsterdam, which are really, really good. So really, guys, thank you very much for inviting me, and really congratulations for this really great event. So I'm gonna spend some time with you this morning to talk about, surprise, surprise, networks. And we'll go through again some of the things we have seen already during the practical workshop in the last few days. But I will also try to take a more theoretical stance and address some of the conceptual questions and problems and the main ideas that are behind this particular way of approaching networks, that is approaching them by actually visualizing them, making them visible. The visualization of network is actually a very trendy way of visualizing information. As you can see from this image, which I found recently in an Ipser coffee shop. When something gets into an Ipser coffee shop, it means that it's kind of trending in society right now. But at the same time, while we found network and images of network nowadays almost everywhere, most of the time, as in this case, they don't mean that much. The visualization is fancy. It some way conveys the complexity and the connectivity between different items, but it is not as if you could really actually read what is here, which is actually a very interesting critique. The Bernard Reader, who gave the first keynote in this sprint, made to network visualization in this extremely good paper that he wrote with Theo Rolle called Digital Methods from Challenges to Bildung, where he says, tools such as Gephi had made network analysis accessible to broader audience that happily produce network diagrams without having acquired robust understanding of the concept and technique that the software mobilize. This, more often than not, leads to a lack of awareness of the layers of mediation network that network analysis implies, and thus to limited or essentialist reading of the produced output that miss the artificial analytical character. Basically, what Bernard is saying is that it is getting easier and easier to produce visual diagrams of a network, and more people are doing so without actually really understanding what it means, and thereby producing stuff that doesn't make much sense. And I have a few examples of this. Next week, Matteo Giacomi will be here and in Lisbon. He is keeping a whole collection of bad ways of visualizing network. These are just a few examples, but you have like hundreds of them. And these are very different type of networks. The one is the network of political contribution in the US, if I remember well. This is a network of the internet or the web. This is an ecological network of fish in the sea, and this is not even a network, even though it looks a little bit like it. It is the logo of the 15th Conference of Parties to the United Nations Framework Convention of Climate Change in Copenhagen, which is famous for being a main diplomatic failure. And in all these cases, you have this visual representation of complexity, which does not convey much, apart maybe the idea that there's a lot of items and they're connected in complex ways. So network and network visualization have become sort of the metaphor of collective complexity, rather than what we should be, that is a tool to make sense of this complexity and to understand it. So today I will discuss a bunch of conceptual ideas and their practical implication for the study of network, trying to make sense of what do we see when we look at networks. There's a paper you can find. The slides of my presentation are already on my website. So if you go on my website, which you have here, tommasoventurini.it, you'll find the old slide set of this presentation, and also this paper, which kind of summarize, which is not published yet in a journal, but is out there, so you can download it and read it, which kind of summarize the most important things that I will talk about today. So the first part of this keynote will try to answer to the question, why are networks so popular? Why are we so obsessed about network and we constantly use them as information visualization? And maybe we need to take like 1 second to think about this we. What does this we stand for? It stands for, in general, our society. As I showed you before, networks are more and more popular and used in all kinds of contexts. But it also has a less inclusive meaning as digital STS scholars. So people coming from this very specific field of research, which is the application of STS, or science and technology studies, to the study of media, social platform, digital communication, etc. And here, for these people to whom I belong, to this community to whom I belong, networks are particularly interesting because they embody a very productive conflation. A sort of combination and to some extent confusion of 3 different things, which are actor network theory, which some of you may have heard of, social network analysis, and digital networks. So as you can see in these 3, these are 3 very different things. I will soon give you a definition of each of them. But they all have in common this idea of network. And because they all share this interest for networks, even though, as we will see, they define network in sometimes slightly, sometimes profoundly different ways, they can, to some extent, exchange and be put together. So actor network theory, as some of you might know, is social theory that has been developed by people like Michel Calon and Bruno Latour and Jean Lowe and others in France and in the UK, but also nowadays worldwide. And reading from the Wikipedia definition, which is, I think, pretty good, actor network theory explains how material semiotic networks come together and act as a whole. These networks are transient, exist in a constant making and remaking, and relation need to be repeatedly performed or the network will dissolve. So basically, the main idea of actor network theory is that collective phenomena, social phenomena, exist because they are enacted, they are produced by the connection among a series of heterogeneous social actors, which is human beings, but also other types of beings, which come together, interact, interfere with one another, and the result of these interferences is what we call society or social phenomenon. So it is, according to me, very interesting social theory because it, as we will see, it goes beyond the classic idea of sociology that there would be individual behavior on one level, and on the other level you will have social structure that defines or that constrains the way in which we behave. According to actor network theory, there's no such a separation, and the old social phenomena are just the interferences between actors and their action. Then you have social network analysis, which is a method that, again, reading from Wikipedia, investigates social structure through graph theories. It characterizes structure in terms of nodes, individual actors, people, or things, and the ties or edges, relationship or interaction that connects them. So social network analysis is a technique of research in social sciences that developed in a completely separate way from actor network theory. It's not the same people. It's not the same communities. They don't develop in the same countries. But but as we will see, they share some idea. And then finally, you have, of course, digital networks, the object which we are all studying in this room. The internet and the web, here you have the definition of Wikipedia, but of course I will not have to read it to you. But again, the important idea is that these technologies are, in a very basic way, founded upon the paradigm of network and network communication. So the whole revolution of the digital technology in the last few years has been, or at least in telecommunication, has been made possible by the introduction in media and in communication of this sort of reticular approach that was not the one followed in traditional media such as television, radio, books, etc. So as you see, these are three very different meanings of the word networks, and yet in the last 20-ish years, that have been brought together by this community of people working around digital STS. And the first, the book that sort of started this whole idea of bringing together these different meaning of networks is a very important book to me, and a very good one, though it's completely forgotten. No one ever, very few people have ever read it. It's called Mapping the Dynamic of Science and Technology. It's by Michel Calon, Jean Lowe, and Ariel Rip. It has been published in 1986. And it contains, in its very introduction, this idea of conflating this different meaning of network. What this book does is introducing some network and quantitative methods to the study of science and technology. Before that, to some extent even after that, most of the studies in STS, science and technology studies, were based on qualitative methods, basically interviews, participatory observation, ethnography in general. And here, Michel Calon and others put forward the idea that instead of studying the actual actor in science and technology and their action, one can study their traces. So they say, instead of following the actor, follow the actor is like the slogan of actor network theory. But what Calon is saying is that instead of following the actors, we may therefore follow the text. He's talking about scientific papers, articles. We may not in this way find out everything there is to know about scientists and laboratories. However, the study of text is well suited to our particular and limited task, that of studying scientific change. And then he says something very interesting. The force of such texts also resides in the fact that they contain links with other texts, references to the literature, work, and institution. In some, texts make possible the construction of linkages between existing entities and the formation of novel entities. So what he's saying is precisely that by looking at the text, and particularly the citation between academic texts, we can study, we have a proxy to study the connection, the alliances, and the opposition among scientific actors, and not just scientists and engineers, but also, as he says, institution, founders, etc. So as you can see, like in this very short quote, you already have brought together the three meaning of networks that we discussed before. So on the one hand, the theoretical idea that collective phenomena are best described not by their substance, but their relation, so that the nature of something depends on the relation that constitutes it, which is the basic tenet of vector network theory. Second, that methodological appeal for new techniques to analyze and represent the connection between social actors, which is the definition of social network analysis. And finally, the intuition that the inscription left by collective action can be repurposed, can be used for social research. The idea that we can work on network data. At the time, this is 1889, and Calon is not thinking about digital media yet, because digital media did not exist, the web and the internet, or were at the very first stage of their existence. Is talking about bibliographical data, so basically data about scientific publication. And yet, you see that he is creating this productive conflation between the three meanings of network. Again, a conceptual topology, so the fact that we are in a space of connection rather than a space of coordinate. We'll come back to this idea later on. A set of computational technique, the mathematics of graphs, which is for the first time invoked in STS. And third, the hypertextual organization of inscription of traces. Again, is not yet the hypertext of the web on the internet, but is the relational data set of scientometrics. And this idea, though the book is not very well known, this idea has become in the last year very popular because it brings together two very promising, separating, and yet to some extent having a lot of affinities, tradition of social research. On the one hand, actor network theory, which has been often criticized for being a theory without a method. So actor network theory is very interesting from a conceptual point of view, but when you read most of the text of this founder, it does not give a lot of details on how you actually should do actor network theory. And on the other hand, social network analysis, which has often been criticized for being a method without theory. So here, on the other hand, you have a lot of instruction on how to treat networks, but you don't have a very thick theory on what it means to be connected, on what it means to be clustered, or what it means to be in this kind of network. So the conflation between these two traditions seemed, from the very beginning, very promising, and yet probably it wouldn't have had the success that he had if it were not for the third type of network we were talking about, the arrival of digital network and digital network traces. And here is a old but also very interesting paper by Bruno Latour. It's actually a keynote that he gave at the Virtual Society annual public lecture, in which he says, once you can get information as BOR, bytes, modem, sockets, cable, and so on, you actually have a more material way of looking at what happens in society. Virtual society, thus, is not a think of the future, it is a materialization, the traceability of society. It renders it visible because of the obsessive necessity of materializing information into cables and into data. So it's basically the whole idea that founds the digital methods movement, that we can use digital traces or digital inscriptions as proxy of social phenomena. And then people as Richard Roger and Ocha Mares take up on this idea and started developing a bunch of tools that actually made it possible to do what Latour imagined and sort of pointed at in this very early keynote, that is using this kind of tracing to understand social phenomena. And here you have one of the very first results or outcomes of this collaboration between Nocha Mares and Richard Roger. It's a map of the political Palestinian web, where you can see a clear separation between the Hamas-related website and the Fatah-related website. So it's this idea that by extracting network from hyperlinks and by looking at them, so I put up this specific image because it's a very early, possibly the first example of a visual representation of a network that is used to understand, in this case, the separation between these two political parties or groups in the Palestinian debate. Show that from the very beginning there was this idea of visualizing network and looking at network rather than just calculating them. But it was not only social scientists trying to exploit the methods of the media, so extracting data and extracting information from digital network. It was also the other way around. So in the very same year, computer scientists and people developing the very infrastructure of the web and the internet that we use today were looking at social research to extract some of the techniques that have been developed in social research. And here you have a couple of citations from two very famous papers, which are basically saying that one very productive way of studying hyperlinks is by applying techniques, methods that have been developed in scientometrics, so the study of scientific literature, to the web. Can you guess who are the authors of these two papers, or what they are talking about? No? No one? These are actually two papers by Larry Page and Sergey Brin, the founder of Google. And the two papers are the two founder papers of the PageRank, the algorithm of the Google search engine. And they basically say in both cases that their algorithm is nothing but an extension of techniques that have been developed in scientometrics. So because you have this happy conflation or felicitous conflation between a theory without a method, so actor network theory, a method without a theory, social network analysis, but also one of the major technological economic innovation of the latest decades, digital network. This create all this interest and increasing success and popularity for network and network-based technique analysis. But as the uncle of Spider-Man always remember, from great power comes great responsibility, and that's why we should now take some time to think about the success and kind of problematize it and see what it means to, if it makes sense to conflate these different type of network. So the second part of my keynote address this very question and ask, even though it seems very promising and interesting and appealing to conflate, to combine these three different meaning of network, are we really talking about the same network? And I think the safer answer says probably not, because there are at least 4 reasons why networks, in the sense of actor network theory, are not networks in the sense of digital networks and social network analysis. I will go through all of them. They have to do with the partiality of digital inscription, with the lack of the heterogeneity of nodes and edges, with the lack of reversibility of nodes and network, and with the problem of the dynamics of relational change. So the first one is actually the easiest one to understand. Even though digital traces, digital inscription are a very good proxy for social phenomena, there is a lot of stuff that is not captured by this inscription. That is something that we should never forget. Because particularly in the kind of methods that we use in the digital method approach, we tend to extract most of our traces, most of our data for platform, and sometimes forget that platform only gives us a very specific point of view on collective behavior. Platforms are not the web, for one thing, right? There is a lot of things that happen, that's still happening in the web outside of the main social media platform. So when you study Twitter, Facebook, Reddit, YouTube, etc., you should never forget that there's also other stuff happening in the web, in, for example, the blogosphere, in just normal website. And then sometimes just looking at a social media platform will push you to lose everything else. That the web is not the internet, even though nowadays most of the internet traffic is the web. There still is a lot of stuff that happens through the internet that is not the web. Think, for example, email and mailing list. The internet is not the digital, right? Again, there's a lot of digital data out there that are not online, that are not accessible through internet connection, that are, for sometimes very good reason, kept safe in a computer that is not connected to the net. But sometimes, depending what you are studying, that's the kind of information that you need. So again, depending on the phenomenon you are studying, also be ready to just leave your computer and go to some archive or some place, some library where this information is stored and preserved. And finally, of course, not all inscriptions are digital. There are still a lot of social phenomena that are traced by other technology, other intellectual technology that are not computer related, and sometimes they might be important. And finally, of course, not everything is inscribed, not everything is traced. There still is a huge continent of social interaction that is not traced in any material technology. So that has to be studied through basically direct observation or ethnography, right? And the reason why they put a bunch of baboons here is that for the famous argument made by Bruno Latour that the only difference between baboons and humans is that baboons do not have access to this inscription technology, not just the digital one, but in general the technology of materialization of social relations, and yet they have a social life that is almost as complex as ours. And we humans also still have a very important share of our collective life that is not, I would say, luckily, that is not mediated by digital or technology in general. And sometimes it might be very interesting to look at this. It's always, depending on what you study, again, like interpersonal connection, what happens between closed door, might be the important phenomenon. So again, it is obvious, but I think it's always important to remember the fact that when we do digital methods, we're only studying a very partial, powerful but very partial view of collective behavior. Also, you have to keep in mind that digital inscriptions are not only partial, but they're also more than just traces. Right? That's why I prefer, even though the term trace is actually easier than the word inscription, the word traces is a bit misleading because it gives you the idea that there is some behavior or some phenomenon happening out there, and then it gets traced in a sort of a neutral way by digital technology. And of course, this is not the case. Tracing is always a form of translation. So the fact of being materialized by a technology, being it digital or anything else, always produce a transformation of the thing that is studied. And you have a very interesting paper by Dominique Boulier. Here you have the French version, but it exists in English as well, where he talks about the 3 generations of social research. And he makes the very convincing argument that depending on the type of traces that are available for the study of collective life, you have not only different type of social research, but also different type of society. So the 3 generations are: the first one is the one based on basically basic statistics. Then you have audience and pools and surveys. And then finally, you have the traces of basically digital traces. And each of them, I don't have the time to go into detail, but each of them have different features. And because of the different features, they not only produce a different type of research, but they also influence the kind of interaction that we can have among each other. The second reason why networks are not networks, why actual networks are not digital and social network analysis, is that according to a very important element for actual network theory is the heterogeneity of nodes and edges. So that's a key message of actual network theory, that there are many different types of social actors. Not just humans, but also technical objects, but also institutions, but also laws, but also natural elements that enters and interfere with our collective life. And this is something that can be operationalized in network analysis only to a certain extent. It is actually relatively easy and possible to have networks that are heterogeneous as for the type of nodes. So for example, what I'm showing here is a network that I created a few years ago about, it's a scientometric network again, and it's about the research on CO2. And you have a bunch of different nodes. You have countries, you have keywords, you have subjects, you have authors, you have institutions, you have references, and all represented in the same network. And when you look at a cluster, a group of nodes, there is a group of different types of nodes. So authors that use keywords, that works in special institutions, that writes in specific journal, etc., etc. What is more difficult to do is to have different type of edges. Because, as we will see later, edges can only be in networks, can only be in graph theory, can only be different in terms of their weight. So they can be stronger or weaker, but then cannot be of different type. And while sometimes it is possible to transform a difference into or implement or operationalize the difference in your edge as a difference in weight, so a quantitative difference, sometimes the difference is qualitative more than quantitative. For example, say that you are doing cross-platform research, and you are able to find out to identify the same actor in different platforms. But then how can you represent the different connection that they have in the same network? So if two actors, if one actor retweet the tweet of another one, is it stronger or less strong than maybe answering to a Facebook or commenting a Facebook post? And what about if you know if they also meet in person? That's probably stronger than just exchanging a tweet, but how much stronger? Is it 10 times stronger? Is it 50 times stronger? Is it twice as strong? So as soon as you put different types of edges on the same network, then it's very difficult to weigh them, and it's very difficult to compare them. And even more complicated when you do, like me, controversy mapping, when you are interested in not in collaboration or alliances between actors, but are interested in their opposition. It is very difficult to operationalize in network theory negative links. So what is it? What if two people are enemies? And we had this very specific problem in a project called Contropedia, which we developed a few years ago, which was about controversy on Wikipedia. And we had a very good trace of controversy, which is the revert, when someone changes someone in a page and then someone else changes it back. This is a very this is a negative action because it reverts the change, the edits made by someone. But then how can you represent it in a network in which, as we will see, edges are always plays the role of keeping nodes together. Whereas here, we would like to put a repulsion force on the edges, which is not, for complex mathematical reason, possible in graph theory. So what we have to do is basically to produce this kind of network was to create a secondary network based on the idea that my enemies are my friends, and my friend's enemy are my enemy, kind of. But it works a little bit, but not as good as it should. The third difference is that in actor network theory, you have this and that's why it's called actor-network theory. You have this idea that actors are networks and networks are actors. There is a complete reversibility between the two. That each entity can be decomposed in the network that builds it. And vice versa, each network can sometimes be black boxed into a single items that then play the roles of one single node in a larger network. So Bruno Latour says it very well. To follow a network is a bit like defining a wave corpuscle in the 30s. An entity can be seized either as a nectar or as a network, and it is in this complete reversibility. A network is nothing except the network that a network is nothing but a network, except that a network is nothing but a network, and it is in this complete reversibility that resides the main originality of vector network theory. And this is something that is actually relatively difficult to do in graph theory, in which you clearly have the network and the nodes, and you cannot reverse one. You cannot reverse one in the other. It is also something that one should keep in mind while studying digital network and social media, for example, because while social media platform gives this idea that there is nothing but the individual accounts and individual pages of that constitutes the network, this is actually not true, right? It is clear that a platform such as Facebook only exists because of a huge technical infrastructure that is completely hidden when you use Facebook. When you use Facebook, Mark Zuckerberg page is exactly as your own page, or any other page on Facebook, right? But of course, the power that Mark Zuckerberg has on Facebook is much greater than those of other users, because he has a power to intervene on the infrastructure, on the hidden infrastructure that is some way behind the functioning of Facebook. So again, in digital life, in online media, this reversibility of complete reversibility of node and network is problematic. It should be taken into account. The fourth and last difference has to do with change, with the dynamic of social phenomena. And Michel Calon says very explicitly, he says reality is a process. And by this, it means that what matters for actor network theory is not stability, is change, is dynamic. And dynamic is actually something that is pretty difficult to implement, to operationalize in network theory. And this is why, if you look at the diagrams that appears in most of the funding text of network theory, you have 3, which I extracted from 3 different papers. They are never network. They look more like flows or other kind of diagrams. Because what was interesting for Calon and Latour and others was not so much the static distribution of connectivity, but more how this distribution changed through time. And in fact, networks are actually pretty good for studying how things move through network, but not so much for studying how network change. So graph theory, at least in the standard application, is very good to study change in network and not so much changes off network, which is what would be interesting for actor network theory. Okay, let's get this. And this is why also in this other paper that I wrote a few years ago, we had to move in order to account for the diplomatic discussion in the United Nations framework on climate change. We have to go from a network representation to this band chart representation, which shows basically the changing importance of each of the cluster in our network. Here's a couple of, here is a couple of papers, one in English and one in French, that basically discuss this difference between actor network theory and social network analysis and digital networks. On the other hand, however, there might be a less negative answer to the question, are we talking about the same network, if we consider not the mathematics of network analysis, but rather the visual representation of networks. We will see why, for some reason, the visual representation of network is, at least in my view, a closer and to some extent better operationalization of some of the idea of actor network theory. If we're able to become sensitive to the different density in association, which is what I think is the basic message of visual network analysis, and I'll discuss that in a minute. So there is one element that is really important that actor network theory and then social network analysis have in common, and it is the privilege, the priority that they give to the relation as opposed to the elements that are connected by this relation. There's a very nice article by Sophie Munsell who compare the two approaches, and she said both of these approaches reject an a priori reification such as the social or society. Both of these approaches consider the production of meaning as an activity of connecting, disconnecting, and analyze how actors come to be created through collaboration of other actors in different contexts. For both approaches, the ties precedes the node. So that's, I think, the departing point of our way of thinking about network analysis. That what we're interested in is not the elements that are in the network, but the relations that connect them and the phenomenon that they produce. On the other hand, however, as for the reason that I just explained, we should never have a naive idea of the relation between, or the correspondence between the network and the phenomenon that is represented by the network. There's no direct correspondence between a relational phenomenon and its representation as a network. The correspondence between the two is more a form of resonance than a direct similarity. And there's a nice book about it by Anna Munzer called Anastasia of Networks, where she says a diagram of a network then does not look like a network, but maintains the same quality of relation, proximity, degree of separation, and so forth, that the network also requires in order to form. Resemblance should here be considered as resonating rather than hierarchy. So there's some form of resonance between relational phenomena and their visual network representation, which we'll try to explore. But before we do that, we need to take a quick step back and consider how network analysis was born. As you probably know, network analysis comes from the problem of the city of Königsberg. This is a picture of this city, and this is a map of the city. Königsberg is a German city, used to be a Prussian city at the time, that is built on the side of the river Pregel, which you see here. And at the time, there used to be 7 bridges crossing the river Pregel and connecting the different neighbors of the city. And for many years, it was German mathematician of the time were discussing the problem of walking through were wondering if it were possible to walk through all the neighborhood, to visit all the neighborhood of Königsberg without crossing the same bridge twice. So maybe you start from here, you go there, you go there, and then you go there, but then you have twice on the same thing, so maybe you go there. And actually, you can try as much as you want, and it's not possible. right? But the question is, how can you prove that mathematically? And that proved to be actually pretty complex until Euler came around and he found a mathematical definition, a mathematical proof of the impossibility of the walk of the Prague River by doing a very classic mathematical operation, which is abstracting, as it says in the quotes, abstracting from the specific topological or geographical, if you want, distribution of the city, and transforming this in a table of numbers, which then he could calculate. And so at that point, in this point, which is the founding moment of network analysis, Euler is going from map to math and basically discarding all the visual quality of the network for their mathematical structures. And after that, for many years, people stopped looking at networks and begin calculating networks. And that was actually really, really powerful, and then allowed a lot of different technological innovation, such as, for example, the train routing, right? Before people thought of applying network theory or graph theory to the train routing, it was basically one train, one line, because it was very difficult to sort of calculate how to have different train going on different lines without incident. And then, of course, the same thing is for telecommunication, right? At the beginning of the telephone, when you had to phone someone else, you had to go through one of these ladies who will say, okay, hello, you want to speak with whom? I want to speak with Jana. And then she takes Jana cable, my cable, and put them together, right? Which is not a very efficient way of routing communication. But then by applying network analysis to the routing of communication, we have like the modern telecommunication media, and of course the internet and the web. And yet what we want to do is try to go back to the visual quality of the network. And this move started quite a few years ago, almost 100 years ago, in social network analysis. Not in network analysis, in social network analysis. So in people from sociology wanting to use networks to study social phenomenon. And the father of social network analysis, which is this very interesting researcher called Jacobo Moreno, who is also weirdly the inventor of the psychodrama, which is a way of curing psychological problems through theater. He also invented social network analysis, or the application of networks to the study of collective phenomenon. And he says very explicitly that, for example, the expression of an individual position can be better visualized through a sociogram, which is like a visual diagram of a network, than to a sociometric equation. So it said it is better to look at a network than to calculate it. And then it will say, if we ever get to the point of charting a whole city or a whole nation, we would have an intricate maze of psychological reaction, we would present a picture of a vast solar system of intangible structure, powerfully influencing conduct as gravitation does body in space. Such invisible structure underlies society and is influencing determining the conduct of society as a whole. So again, he's saying we should picture visually the way social structure influence individual behavior. But even more than these quotes, this image, which is taken from an interview that was published in 1933 on the New York Times to Jacobo Moreno, gives this idea. So the title of the interview is Emotion Mapped by New Geography. So you really have this idea that network, as Moreno calls them, sociogram or network diagrams, should be read as geographical maps, very clearly. And then he gives this example, which is a very good one, because this example shows the connection of friendship in a primary school class in New York. And if I tell you that the triangles are the boys and the circle are the girls, you can immediately see how in primary school is a bad thing to say that you're a friend with someone of a different gender. Even if you are, you would certainly not say it. That's why you have all the girls all the boys connecting among themselves and all the girls connecting among themselves, except for this one boy who says that he's friends with this girl, but unfortunately she doesn't reciprocate. And so you see the idea of emotion mapped by image graph, even if it's very simple kind of map. However, if you think about it, this is clearly not a geographical map. It is not a geographical map because in a crucial way, the space in which the elements are represented do not pre-exist the elements that are represented in it, right? So this is a geographical map. This is a map of the London Tube. It's the map that was available until 1933. And it is a geographical map. It has been drawn by first drawing the two axes and then projecting the station on the space that is defined not by the station themselves, but it is defined by the two axes. On the other hand, this map, which was designed by Harry Beck in 1933, and which sort of look a lot like the modern map of London Underground, this is not a geographical map, or is something in between. Because what the great idea that Beck was the first one who had this idea, is that when you are using the tube, the underground, you don't care so much about the geographical distance between the station. What is important to you is their connectivity, whether they're on the same line or not, whether it's like easy change from one to another, etc. So we design all the map going from this geographical map to this network map, where nodes are close not so much or not only if they're geographically close, but they're close if they're connected to one another, which is exactly what Moreno is doing here. Like he did it manually, but it's exactly what it's doing. It's easy to read that there's only one connection between the boys and the girls because he designed all the boys on one side and all the girls on the other side. If he had mixed them, it would be much more complicated to read it. So Moreno is manually and in a way intuitively using what, for those who have followed my workshop yesterday, what I introduced as a force-directed spatialization or layout algorithm, such as forced atlas, for example. And here you see like a few captures of what a spatialization algorithm does. As I said yesterday, it simulates a system of physical forces in which nodes are given a repulsion force, so they push against each other, and edges works as springs or rubber band, keeping connected nodes together. So when you launch the algorithm, it tries to unfold and change the position of the nodes until it reaches an equilibrium in which the attraction force and the repulsion force are in balance. And this is a little bit the magic of force-directed algorithm. After this equilibrium is reached, then the space became significant. It became meaningful. Like here, the fact that when you randomly spatialize the network and position the node, the fact that two nodes are close doesn't mean anything, right? It's just random. But here it does mean something. So the fact that two nodes are close means that they are either directly connected or indirectly connected. But anyway, that going from this node to this node is probably much easier than going from this node to another node up there in terms of the number of steps that you have to go from one to another. And this is like, it's a little curiosity. This is the same network of the same sociogram of Moreno, spatialized with forced atlas 2 by Martin Grandjean. And you see that when it's spatialized with an even better explicit force vector algorithm, not only it remains very easy to see the only one connection between boys and girls, but you can also see other things that were not clearly visible here. for example, this little clique of boys that are friends among themselves, but not so much with the other, is somewhere there, but it's not easy to see. Whereas here you can much more clearly see this different connection, as well as, for example, which nodes are more central, which nodes, as I said in my previous tutorial, which nodes are bridge between different parts of the network. For example, this node that connects this clique of boys that would be otherwise completely separated to the rest of the network, or like very central node like this one, for example, that connects all this part, that is basically very central in the boys group, or a girl here, for example. So we can now read our network, because it is being spatialized with a force-directed layout, as if it was a geographical map. So we can see territories, we can see central and center and periphery, we can see bridge. So we can use all this kind of spatial metaphor to make sense of what we are looking at. On the other hand, and I showed this image to some of you yesterday, network maps are resemble much more to natural geographical maps than to political geographical maps. In political geographical maps, the borders between the different territories are clear-cut. They're easily they're easy to observe, right? Whereas here, for example, there are borders, there are separation between different territories, but they're easy to observe, but they're not easy to point at. For example, the difference between the plain here in France and the Alps is obvious. Right? You see that here is flat and here you have a mountain chain. But where the mountain chains start exactly, it's difficult to say, right? And this is also true for network maps, right? So sometimes it's easy to say, okay, here there's a clear separation between two because there's no connection between them, and maybe also between boys and girls. But if you look at the boys, for example, yeah, this one is clearly separated, but then what about this thing? Is it one big cluster? Is it 3 cluster here, 1, 2, and 3, or maybe just 2, 1, and this bigger one? So you see what I mean? It's always, networks are ambiguous. They never explicitly tell you where a cluster stops and when another begins. And to some extent, this ambiguity is productive, right? It's actually something that should not be you should not be afraid of. And it is, in fact, to some extent, it is a nice way of representing an ambiguity that does exist in social life, right? In social life, you often have this sort of complicated, unclear, blurry boundary, whereas you're not sure whether something is part of something, whether it's close but not really part of it, etc., etc. And in fact, there is this nice paper by Joanna Drucker called Humanities Approaches to Graphical Design, which I really recommend, where she's not talking about networks, she's talking about more classic form of data representation, such as bar charts here. And she said, and she's particularly specifically criticizing them because they do not allow for conveying the ambiguity that's inherent to social phenomena. Here, for example, the example that she gives is this example of a bar chart of genders, so women and men, or female and male. And then she said, but of course, we all know that, good social scientists at least, know that gender is much more complicated than this, and that in some that is more mixed, and like in some population, there's no you don't have a gender until a certain age. That there are people that feel that they have 2 different genders at the same time, or no gender at all. There are people who gender changes through their life, etc., etc. And so what we would need are more blurry and ambiguity compliant way of representing our connection. on the other hand, if this ambiguity is, to some extent, a good thing, I also have to tell you, to be completely honest, then there is also a part of ambiguity in network visualization that is actually just an artifact of the fact that we are visualizing in a two-dimensional space a multi-dimensional mathematical object. So, and here you have an example of this, which is pretty clear. If you have a network such as this one, then you can represent it perfectly in a two-dimensional space, because then this node and this node are twice as far as this node and this node, because they are twice as far in network terms as well. And you can design, if you think of a clique, so a clique is a fully connected network. If you think of a clique of 3 nodes, you can perfectly design it in a two-dimensional space as a triangle with equal size of equal size. But if you have a 4 nodes clique, such as this one, there is no, and it's actually a very simple network, not a very big and complex one. But there's no way you can represent it correctly in two-dimensional space, right? Because all nodes are connected in the same way, so they should all be at the same distance one from another. But there's no way you can put 4 points at the same distance in the space, because like this, the diagonal are always longer than the sides of your quadrilateral. And so even for such a simple network, there is some distortion due to the flattening on a two-dimensional space. And of course, when you are working with networks of hundreds of dozens of hundreds of thousands or hundreds of thousands of nodes, there is even more of this kind of distortion, which means that sometimes part of the ambiguity of the network comes from the fact is an actual distortion of the projection due to force vector. However, there are mathematical evidence. There's no definitive proof, unfortunately, but there's some good mathematical evidence that there is a strong correlation between visual clustering in networks spatialized with force-directed layouts and modularity clustering, which is a mathematical way of measuring groups, of detecting groups within networks. For example, for those who are interested in mathematical, in the mathematical networks, I recommend this paper by Andreas Noack, which is called Modularity Clustering is Force-Directed Layout. And here you have a visual representation that I created a few years ago. This is a neural network of the C. elegans, a worm. And the color of the nodes, so the position of the node is done through Force Atlas 2. And the color of the nodes is the modularity class, the modularity group, calculated through Newman modularity. Newman modularity is a measure that basically maximizes the connection within a group of nodes and minimize the connection to other groups of nodes. And as you can see, there is a quite strong correlation, not for all groups, but there's a quite strong correlation between color and position. So the nodes of the same color ends up being the same space, right? Which is not at all obvious, because the color depends on a mathematical measure of grouping, and the position is produced by a force vector algorithm. There is, of course, there are, however, as you can also see, some distortion. For example, this pink cluster here is very much spread in the network, and there are some nodes. For example, this node here is mathematically, this green node is mathematically belong to the green cluster up there, but it's here and not there, and the same for these two pink, for this pink node. So there is still, there's still a part of distortion, and unfortunately, what is actually very difficult to know is, which part of ambiguity comes from the data and which part of ambiguity comes from the visual distortion. And we have tried to work with Matteo Giacomini, who's going to be here next week, a lot on trying to separate the two, but for the moment we have not found a convincing answer. However, to close on a more optimistic note, there is something very interesting about visual network, which makes them capable to, as I said before, to operationalize some of the conceptual idea of actor network theory. And in particular, this idea which I briefly mentioned before in my talk, that there is no separation between a micro level and a macro level. So for those of you who have followed any sort of has a sociological background, know that this is a very classic distinction, possibly the most classic distinction of social theory. That there would be, on the one hand, individual interaction, what is called the micro behavior or micro interaction, and on the other hand, a macro level of the social structures, and then the two would be separated. And that's a very old idea. You see it, like, for example, the extremely famous book by Thomas Hobbes, the Leviathan, and this is the cover of the book. And in the cover of the book, you have the Leviathan, which is the state for Hobbes, which is represented, probably you can sort of see, but his body is built out of little bodies of the citizen of the state. And this is the idea that the state, so the Leviathan, emerge as this kind of mythical monster, the Leviathan, from the connection of all the interaction between its citizen. But once it has emerged, it has become something different. It exists on another plane, on another level of existence, if you want. And this idea is also often captured by the metaphor of the ant and the ant nest, right? Which is like recourse all the time in the writings of various fathers of sociology, where they say, in the same way as the ants build their nest without knowing what the nest look like, so humans build their society without knowing what the global structure look like. And these global structure are emerged on another level that is different from one of the interaction, as the ant nest exists on a different level than the ants. It turns out, however, that this is not actually true. It is not true for ants. Ants do have some appreciation of what their nest look like, so they're not just interacting on a totally local scale, but it's also certainly not true for humans. Here, for example, you have but there are plenty of other papers that prove this idea, but this is an interesting example, and it shows the evolution of a city. Can you guess which city is it? No, it's not Amsterdam. No, it's in France. It's Paris. It's actually Paris. This is the sun that you see here. Anyway, and it's a paper that asks the question. I explicitly asked the question: the structure of city is created just by the self-organization of the city inhabitants, or it depends on the big structural reform made by the city urbanist. And in Paris, as you know, the Baron Haussmann at some point made a huge transformation of the grid of the city. So the paper is studying whether this transformation is more or less important than the self-organization of the Parisian citizen, and it actually showed that both are true, of course, right? So that both dynamics exist, that they are sort of they interact one with the other. I will not go into detail, but basically this idea that we understand much more of the evolution of the city of Paris by considering together the micro interaction between the citizen and the macro reform of the Baron Haussmann, rather than considering just one or the other. And I have another simple example of this. which is this one, in which this is a very nice but completely illegible graph by, I don't remember who made it. Anyway, it's a graph that shows the recycling practices of HBO, the television chain in the United States. And here on this side you have the TV shows, Sex and the City, Oz, The Sopranos, 6 Feet Under, etc., etc. And here you have the actors. And you can see that most of them are present in more than one show, so they are recycled, right? But like this diagram is not very legible, because apart to see that most of people have more than one connection, it's actually impossible to see to which show they are connected. And this is because the person who designed this graph, for some reason, decided that it should separate the individuals and the shows. But if you take the same network, which is what I did here, and you allow the two types of node to mix, so instead of pushing them to in different layers or different layers, you let them mix and spatialize with the force vector algorithm, then suddenly you can start seeing more interesting things. Not only is it easier to see who's connected to whom, but you can also see that there are actually clusters of different types of series and actors that are more connected to this type of series. For example, here you have all the kind of gangster series with The Sopranos, Boardwalk Empire, Entourage, and all the actors that are there. And then up there you have the more like fantasy kind of website. And here you have like in the center you have the more like social, like modern, contemporary kind of series, which is something that was completely invisible here because the author of the image really wanted to separate one and another, but it becomes very easy to observe when you actually let the two things mix. And so this is a very simple and to some extent a stupid example, but it gives this idea that sometimes there is stuff which is very, I think, deeply grounded in network theory, that we understand better social phenomenon when we start by looking at connection and leave things sort of organized according to their connectivity, a little bit as we do in with a force vector algorithm, rather than starting from separating things just because some are micro, some are micro, and they're putting them in different boxes before we start observing their connection. So while a little bit as in Magritte's famous paper, this is clearly not a social network, and this is clearly not a digital network, this network representation, to some extent, can provide some interesting insights about the phenomenon that they represent. When we accept that they are not when you said that the way in which they represent social phenomenon is not a direct correspondence, but it has to do precisely with this idea of different, which is what we have been observing all the time, different density in the association between nodes. So there are nodes that are slightly closer, others that are far away, and this sensitivity to the different density of association is the main message of vector network theory. That we should be able to follow the connection between social actors through their heterogeneity without looking for clear-cut boundaries, but at the same time, not by mixing everything, but by being able to understand, by being able to capture the different density of connection between different parts of the social world. And I'd like to conclude with a quote by sorry, it's nothing to do here, from Bruno Latour, which I think captured this idea of how we should think of network. It's from here. Sorry, it's the wrong. Here you have the right reference, and it's a very nice and funny dialogue between a professor, which is like Latour himself, and a student. And so the professor says, "You should not confuse the network that is drawn by the description and the network that is used to make the description. And the student is like, what? And the professor said, but yes, surely you'd agree that drawing a pencil is not the same thing as drawing the shape of a pencil. It is the same with the ambiguous word network. So we use network to not because we are drawing the shape of a social network, but we use visual network as a tool to draw a social phenomenon and to observe them. Thank you very much. This is it. You can find the slides and the paper that I talked about on my website in case you're